Okay, I think we're on our fourth week, is that right? Okay, start of the fourth week. I posted a video this morning. Seems like it was so long ago, but I got up at 5 and I gave an overview of where we're at and where we're going. After I did that this morning, I got an email about something about a date, President's Day. I think campus is closed on President's Day, but I didn't realize that when maybe I didn't check it. So I've got a schedule doing something, but obviously we won't be February 19th, right? It's a Monday. So I'll make whatever adjustments we need to make. I think we have a test scheduled for the Wednesday. As we get a little closer, we'll see if that still makes sense or not. We can put it off a day. We'll discuss it when we get closer. Yeah. Okay. So what we have scheduled today. Let's see. This is too confusing. I'm trying to watch my live stream, but it's like a couple minutes behind. So maybe we'll figure out a way for those who are live streaming to get messages to me, but for now, we'll just be here. Let's go ahead and start off then with the word of the day. Anyone have some inspiring or mediocre is fine too? What would be a good day? Word of the day. Cookie. Wonderful. So we're going to go with cookie. Cookie. You can choose what kind you like. Chocolate chip, oatmeal raisin, whatever. So cookie's the word of the day. To get us started, what we're going to do today is take a look at lesson 3, which is getting us into equations. So let's see if this all... There we go. So we're going to look into solving equations, and then before our next test we have chapter 4, which we're scheduled to do 3 today and Wednesday. Wednesday we may transition into 4. We'll see how it goes. And then we've got next Monday to take a look at 4. Then we've got 2 days, sort of, to do the practice test, and then we'll have our first test over units 1 through 4. What we do today will lay the groundwork for lesson 4 as well, because it's really, all we're doing is we're talking about how to figure out what x is when the two sides are equal. In chapter 4, we do the same thing, but they're not equal. One side's bigger than the other. But it's with the one exception, everything's the same. So we'll look at the one thing that's different, but other than that, Chapter 4 is a lot like Chapter 3. So the time we spend in Chapter 3 getting good understanding will pay off when we get to 4 and we say, we've seen this all before, it's just one side's bigger than the other, and that's all we gotta deal with, a little bit of extra stuff there. Okay, so let's go ahead, take a look at solving equations. Online homework, online quizzes, and if you've, a couple people are starting to contact me. I haven't actually started into the grade book because all I want you to do is focus on learning at this point. We'll get everything, don't worry about due dates because there are no due dates. We'll get you all caught up and I'll update you. Yes.
We get points for the media lesson, right?
If you need them, we can make that happen. But I don't really have it in the schedule. Media lessons are really there for your benefit. So if you do them, if they're helpful. If it's not helpful, I don't want you to do it. That's the main thing. I don't want you doing things just for points. So if it's helpful, though, do it. And we'll make sure that if you're learning, everything will be there. Yeah. So I think I've got it where you, basically the online homework and the online quizzes are where the points come from. As long as you're learning, we'll make sure it works. Yes.
When watching the YouTube video, do I put my comments down in the comment section? Is that where I'm asking a few questions? I wasn't sure where to ask questions when watching.
So the media lessons, these ones?
No, when you're streaming.
Yes.
Do I ask the questions under the comment area, or where do
I think so.
Okay.
But the problem is I haven't been able to respond to those because there's a delay in them, and I haven't been. And when I tried to pick them up, it's like I mess up. My other class, I never switched over to the screen, so all you see is the camera's on my face, and I'm talking about solving problems, and I'm solving them, but I never got it switched over. So if you're watching the live stream, I don't really have a good way for you to ask questions yet.
Okay. That's what I was wondering.
Yeah, and if you're watching the recorded version,
no.
But send me emails if you do have them of questions, particular questions. Do that. And I've found two ways to answer math questions. One is to kind of do a screenshot, and I'll send that to you. Sometimes I'll even make a little video, upload it to YouTube, and then I'll send you the link to it personally, and then I'll post it in Canvas so that others who might have that same question will do it. Because once I'm set up, I can bust out a few problems, just as like writing on paper, but it's recording it. So yeah, if you have I'd like you to see work question 5 on the quiz from Unit 2 or something. You can be as specific as you want or type it in the email, and I'll do those. So video on request. So okay. Yeah, and if you got your children's homework, no, I might not be able to help with that. But we'll do what we can. Okay, so these are the media lessons. We'll just go ahead and open up the workbook, and we might, there's this thing with the story of X thing. We'll look through a few of them, and then I'll also tell you that we don't have to worry too much about it. It's a method that you can use that might be helpful, but if you don't find it helpful, you don't have to use it. So these are in the media lessons, so I don't want to do too much specifics. But at the beginning, what these ones are doing is they're giving us the solution, and they're asking us to check the solution, because very quickly we will be finding the solution, and we're going to have a way to check it. So they found a solution, or they found an answer, and they basically want us to verify whether it's a solution or not, whether it's the correct solution. So what we can do is we take this value, this -3, and we plug it in for the x's, each of the x's in the equation. And how do we know if it's a correct solution? What kind of result do we get?
You're going to get the same result, right?
Going to get the same result on both sides. We'll get 2 equals 2 or 3 equals, we'll get both sides are equal. We don't know what number we're going to get, but we get both sides are equal. So let's walk through it. And then if it isn't equal, then that wasn't the right solution. Okay, so we don't have any steps to do. We're just going to plug -3 in for x. So we're going to have 5 times -3. So notice the -3 replaced the x minus 2. So I did that. That's the left side. Equals 8 times -3 plus 7. Okay. Then what do? We just do the math, right? So 5 times -3, -15 minus 2. And while we're at it, let's just go ahead and combine these. And what do we get? -15 minus 2, -17. Signs are the same, so we actually add them. We get 17, and the biggest is negative, so we get that. 8 times -3, -24, plus 7. Now here the signs are different, so we're going to actually subtract. 24 minus 7 is 17. And the sign on it, since 24 is larger than 7 and has a negative sign, the negative sign sticks. The larger value, the larger magnitude. And is -17 equal to -17? Yes, it is. So we verified that solution. Now, if we got anything else, -17 equals 6, that's not true. So anything else, then we would know that -3 was not the correct solution. Okay. So this brings us to the important concept when solving equations. What does this symbol mean? Equals. Well, what does equals mean? You have a left side and you have a right side, and they're balanced. They're the same. They're equal. But I wanted to use more math. They are exactly the same. Let's put it that way. They are equal, and it's a balance. And that's a good way to think of it. That both sides are balanced. And that's going to help us as we go to solve it, because we're going to see if we do something to one. And basically, this gives us a lot of mathematical power, because when we go to solve equations, we can do any darn thing we want. And that's as close as I get to swearing. Any darn thing we want. And I'll drink my milk in a dirty glass, right? That's we'll do any darn thing we want as long as we do it to both sides. Because if we make a change here, but we make the same change here, we maintain balance. Okay. If we add something over here, as long as we add something over here, we're still balanced. Take away here, take away the same thing, we're still balanced. Multiply here, multiply there by the same thing, still balanced. That's the whole properties. That's really what we're doing. And the cool part is we really can do anything. Even something that nobody else does, it might look wrong in the first step. It might make us do an extra step, but we can still do it. It's still legal as long as we do it to both sides. Okay, isn't that kind of cool? You can't make a mistake as long as you do it twice. Usually if we make a mistake and we do it twice, that's a problem, right? But in math, it's not. Okay, so that's what we're going to be working towards. These first few listed ones are to verify solutions, or just plug them in, see if you get the same thing on both sides. If you don't, then that wasn't the right answer. Somebody made a mistake when they found the answer. So we just said, nope, it doesn't work. Let's see. I think this one here, we'll just do a quick one, right? We're plugging in -1 for m, right? So we get -1 plus 9. The other thing that is nice is if you can get in the habit of just kind of doing step-by-step, working down, giving yourself enough room. One of the things I see is, in fact, I worked with a student who was just very evident. She was trying to squeeze into this small space. She kept getting it wrong, so then she'd bring them over to the paper, give herself room, she'd always get them right. And I said, you gotta, you're trying to constrain yourself to these small areas. You don't need to do that. Just go to the scratch paper off the bat. And a lot of times that's all it is just give yourself room to see what's going on. Oh, I don't know if this will work or not. And then we've got, 3 times -1, plug it in for m here, plus 5. -1 plus 9, 8, a positive 8. And then we get a -3 plus 5. Now some people say that's 8, 3 plus 5, but no, signs are different, so we subtract, and we end up with 2. Is 8 equal to 2? No. There's no variable, there's nothing we can do. This is wrong.
You forgot the -1, right?
Oh, no, I combined it with the 9.
No, the second side. Because it
Oh.
was 3m.
Right.
So it's,
3 times
oh, because it's
-1.
just 3.
Yeah, which becomes -3.
Gotcha. Okay.
Good. Thanks for, yeah. And the -3 plus 5 is not 8. It's not -8. It's positive 2. Okay. So this is wrong. Nope, this is not a solution. And we'll learn the techniques to figure out what it is. In fact, well, we'll come back to this one. This is like one of the more advanced problems. In fact, maybe we'll circle it and try to come back particularly to it, because we could do it now, but it's like starting at the end of the story. And we want to start in the beginning, right? Maybe. Okay, so I'm going to take a screenshot. And the other thing is, let me just check this. Because I don't, if you checked the video from the last day, from last Wednesday, I think my screenshots were small. It wasn't getting the full screen. So I'm going to check to make sure it gets the full screen here, hopefully. If it's not, I don't know what to do quite yet, but hey, it got the whole screen today. Good. I don't know why it wasn't the other day. It should just get the whole screen, right? Okay. And then I'll get a new page. And remember, I can always come back to that page if we need to sort of. Okay. So some more verifies. And verify, verify, verify. Now here's the story of X. And I'll show you how this works with a simple one, and then I'll show how it works with a complex one. You can do this, or we can skip over it as well, because I'm going to show you another method. So this is one method that sometimes works and sometimes it helps explain things. So, because we did a little bit of the story of X thing before, didn't we? Let's go with Violet this time. So the story of X and the expression X plus 7, and use this to determine the solution to the equation X plus 7 equals 8. Okay, so story of X. We start with X, and what do we do with X? What's the first thing we do to X?
You add 7 to it?
You add 7 to it. So okay, so here's it's not real helpful here. So how do we get X? So to get back to the story of X, we have to work backwards. So if we work backwards, what do? What's the opposite of adding 7? Subtract. So what we do is, the story of X basically tells us what we need to do. So we're going to subtract 7, because that's the opposite of adding 7. And since it was balanced in the beginning, what do we have to do to the right side? We have to do exactly the same thing. Now on the left side, notice I've got it lined up with the 7 because I can only add and subtract like terms, right? I can't take -7 from X, but I can take -7 from +7. Okay. So what happens when I take +7 and -7? 0. So it cancels out. This is the goal. Some people says, well, why did we do that if it just goes away? Because we wanted it to go away. Okay. So we're left with X on this side, And what do we have on this side? 11. Okay. And then the check is you take x plus 7 equals 18, and then you replace the x with 11. And let's see if that works. 11 plus 7, yeah, that's 18. 18 equals 18. It checks. Okay, so it kind of gets back. This is what they have you do at the beginning of the lesson. And then during the lesson, what we're going to work on is how to get x by itself. So story of x, what the story of x helps you to do is it gets you the order that things are happening in. And so then when we go to solve, we go backwards and opposite. Now remember, I was telling y'all, if you were kind of a little bit rebellious growing up, that's a good trait to have when you're doing algebra solving, because you got to be rebellious. You got to do the opposite of what they tell you to do, and you got to do it in the opposite order. So, in fact, one of our faculty members, Aaron Jesse, had this to say. What do we usually call order of operations? There's some letters. PEMDAS? Okay, so usually when we're doing math arithmetic, we're going in the forward direction. We call it PEMDAS. Well, he teaches his students that since in algebra, when we're solving, we actually go backwards, and PEMDAS backwards is SAD MEP. So just remember SADMEP. Everything's going to be backwards. It's kind of cool. I had never thought of that before, but some of his students told me that that's what he taught. So that's cool. SADMEP. Nobody else knows what you're talking about, but you're just fine with it. SADMEP. We're doing backwards. So again, mostly what we're going to see today, we're doing either subtraction or addition first, even though, again, we were taught that we're supposed to do it last. Then we do our multiplication division. And if we need to, we won't be doing anything with exponents, but if we needed to, we would do those. And then we deal with the parentheses. Okay, so that's kind of how this whole works out. So again, we'll save another screen here. And we'll just keep moving forward. So I just want you to kind of think in terms of what this story of X is doing, and I'll show you kind of how it can work. In some instances, I think it's a little bit of overkill, but let's just take this one example. And again, you don't have to use the story of X. You just have to be able to solve. So we'll see. By the time we're done, we'll solve this a couple other ways too, or at least one or two. So we've got this equation, and we've got it equal to 5. So let's look at here, what's the story of X? What's the first thing that happens to X? We add 1. So starting with X, we add 1. Then what's the next thing that happens after we add 1? We multiply by 2. I'll just abbreviate that. And then the final step, subtract 3. So, using SADMEP, going backwards, we can solve this by adding 3, dividing by 2, and then subtracting 1. Do you see how that's going to be? So in the solving part, we're going to add 3, we're going to divide by 2, and then we're going to subtract 1. So this is kind of like, any of you play chess? Used to. I was never very good. I taught in Kazakhstan for a year. I told you, and all the 7th graders, they'd come get me out of my office during office hours because they knew I was an easy mark, and they would beat me bad. Because they were always taught to think 2 or 3 plays ahead. And some of them were 5 or 6. I could barely think of the next move, let alone be 5 or 6. This method helps you to be able to basically think, what are all the things I'm going to do to solve something before I even start about doing it. And now let's go ahead and write it out and see how this works. X plus 1 minus 3 equals 5. And what we add to this is, as we're solving, whatever we do to one side, we do to the other. Let's go to blue. So the first thing is we're going to add 3 to both sides. Okay. And notice when we're working both sides, I think that's what those lines are for. The equal sign is the border. It's the place where the balance is, left and right, left and side. So we add to both sides. So be careful. I've seen some people, when they're working these, they'll add 3 to the same side. And there's a problem there, because if you add 3 and then add another 3 to that same side, you've just unbalanced it by 6. Okay, does that make sense? So just make sure you're really on the left and the right-hand side as determined by the equal sign. Okay, what's negative 3 plus 3? 0. One of the things we're doing when we're doing algebra is we're making zeros and we're making ones. You'll see the next step we're going to make a 1. But we're making zeros and ones. And that's exactly what we want. Some people are going, well, why are we doing this? It's just going away. Exactly. That's why we're doing it. What's 5 plus 3? Good. And then what's left on this side? 2 times x plus 1. Now there's another method where we could have distributed by the 2, but watch, this story of x is really going to take it all. So instead of distributing it, what are we supposed to do next? We're supposed to divide by 2. So switch colors again. Divide both sides by 2. Does that make sense? Because it says we were going to multiply by 2, but we divide by 2. So when you take 2 divided by 2, what do you get? 1. So there's the 1. We're making zeros and ones. That's what algebra is all about. My 2 favorite mathematical numbers, 0 and 1. Both are great to multiply by, and they're easy to add. You add 1, it's just like counting, right? So it's really nice. 8 divided by 2, they sort of cancel, but that leaves us 4. 8 divided by 2 is 4. So now we have x plus 1. We don't really need the parentheses because there's nothing being multiplied by it. Equals 4. And what does our roadmap here tell us the next thing to do? Subtract 1. Again, we're doing the opposite of what the story told us. And so we'll trade one more time. We'll go to red. We'll subtract 1 from this side and we'll subtract 1 from that side. Legal, right? As long as we do the same thing to both sides. What do we end up with? Just x on this side, because those positive 1 and negative 1 cancel. 4 minus 1. So the check is you could place the 3 back in. Let's maybe do a visual check. If I put a 3 here, what happens? 3 plus 1 is 4. 4 times 2, 8. 8 minus 3, 5. Does 5 equal 5? There's a check. Kind of sloppy, but you can do the checks mentally. You don't have to write it all down. It doesn't have to look pretty. It just has to be right. Okay. Sound good? So the story of X is something that is a tool you can use to kind of figure out what is happening so that you can make it unhappen. Okay. That's all it really is there for. So I'm going to take a screenshot. Start with a new page. And what we'll start doing is we'll start looking at where the lessons used to start was like right here. Okay, so these are what are called one-step solution, one-step equations. There'll be one thing we do, and we'll have our answer. Okay, so these will get us into practice. And remember, the thing we do is always the opposite of what we're supposed to do. Okay, so we'll just walk through a few of these, see how it works. There's video examples of them, but that's okay. Okay, so x plus 7 equals 18. Again, I like to divide off both sides. I just put a line down here. So what's happening to x? Adding 7. What's the opposite? Subtract 7. What we do to one side, got to do to the other. I've got some students who don't do it on the one side. They know this is going to disappear, so they just subtract 7 from the other side. But they really, they mentally do this thing. So some of you have different mental techniques that you use, and that's perfectly fine to stick with it. I'm not going to grade you on what work you show. That and when I talk about showing your work, I will say you've done a good job if tomorrow or the day after tomorrow you look at your answer and you know how you got it. Then you showed enough work. You showed enough so you know what you did. Or you could explain it to somebody, right? But if you look at it tomorrow and you have no clue how you got the answers you got, you don't know what you did, you didn't leave yourself enough notes. You didn't leave yourself some breadcrumbs to know how to get back. So don't think about what I need to see, because I really don't need to see anything. Think about what you need to have down so that tomorrow you come back, you know what you did. And if you're like me, you think you're going to remember everything, and you realize that you won't, but you learn. It's a learning process, okay? So, and sometimes writing down too much is just as bad as not writing anything down, because you get all messed up. But you'll work out that detail for yourself. Okay? Show enough work so you know what you're doing. So x equals, notice the equal sign stays here, 18 minus 7, 11. I think we already did this one, didn't we? Or something like it. And if you could just do a mental check, 11 plus 7, yeah, that's 18. Okay. But these are the techniques we're using. And some people will just look, well, something plus 7 is 18. Well, that must be 11. So some of you are just solving it in your minds, but this activity of doing the opposite, you're going to find is going to be helpful, because we're going to, when we get to multi-step ones, sometimes you just can't look at it and solve it. But I've got students who will just look at problems, the one steps especially, and they just solve it, and they're not quite sure how they're doing it because they're doing it so fast. But that's really what they're doing in some senses. They're thinking, what plus 7 is 18, and they just figured it out. Okay, so we'll keep going here. So r minus 4, what's the opposite of subtracting 4? That tells us exactly what we do. Whatever we do to one side, better do to the other. Keep the balance, right? I always get this picture in my mind of two cousins. I got an ice cream cone for one. I better have an ice cream cone for the other, right? Or trouble's going to break out one way or another. You got to be fair. Whatever you have for one side, make sure you have for the other. You bring in some nice sweets, make sure you got enough for all of us. Okay. So again, the negative 4 and the 4 cancel, so we get our negative 5 and 4 gives us a negative 1. Okay, and go through the, the calculations. I know some of us are still struggling with signed numbers. That might be an issue you have, but a negative and a positive, those are opposite signs, so we're going to subtract. 5 minus 4 is 1. The 5 is bigger and it's negative, so that's why I've got negative 1. So far, so good? Some of these, let's go to 4, because this throws some people off because the m is on the wrong side. It's on the right side, not the left side. Is that a problem for anybody? Is it an inconvenience for anybody? Does it look a little bit harder if you see this one? No? We can. So I'll show you 2 ways to do it. The first way, if you're uncomfortable with this, you could just easily, the equal sign is ambidextrous, which means it could go either way. This is the same thing as 19 plus m equals 3. So if this side, what I just wrote down, if that looks easier to you, go ahead and switch the equal signs. And eventually you'll find out that you can work either way. Okay? So we'll go ahead and work it the way it's set up. So what's happening to m, the variable? We're adding 19, right? So what should we do? Subtract 19, minus it. And again, whatever we do to one side, do the same thing to the other. And again, it's, these are the sides. 19 minus 19, 0. It disappears. Here's our m. And on this side, 3 and negative 19, opposite signs, so we subtract, right? So that's going to give us 19 minus 3 is 16. And it's going to be a negative 16 because the 19 is the larger number and it's got the negative on it. There we are. Okay. We could have done the same. If it's easier, go ahead and switch it over. Subtract. This might just be like more natural, less likely to get a headache. I mean, believe me, I'm a math teacher who got headaches from doing math until I found techniques that stopped me from getting headaches. And some of it was just doing it in a particular order. And to me, when I was learning it, this was a very difficult way to work it. This was easier for me, so I would switch it. Notice it gives me the same answer. And after years of working them both ways, then it flows. But it didn't at the beginning. And it didn't for several years. Okay, yes?
Could you write that as negative 16m? Do you need the equal sign?
Yes, you do. Because we're saying that m is negative 16. The question was this: could I write it as negative 16m? Now this is negative 16 times m, where what we're doing is that m itself, we've unveiled its identity. We know it's negative 16. But this is, yeah, good question. Nope, that's not. So we always have to have that equal sign. 5. What are we doing to y? Good. So we're multiplying by negative 3, so we better divide by negative 3. Okay. So, and with division, we divide by exactly the number we need to divide. Okay. So some people say, well, let's divide by positive 3, but if we do, the negative doesn't go away. So now notice negative 3 divided by negative 3 is positive 1. That's what we want to create. What we do to one side, we do to the other. So this side, we get a canceling of the negative 3's. All that's left is y. And literally, we talked about this, what coefficient is in front of the y? 1. We could write it as 1y, but that's what we're looking for. And then 42 divided by 3, negative 14. Oh, wait, a negative divided by a negative is going to give us a positive. So positive 14. Good. So far, so good. And again, this is actually when we get to fractions. When we're solving equations, fractions aren't going to scare us anymore. At least they might still scare us a little, but not as much. Because what do we want to see this x divided by 6? X over 6, as I gave it away, as x divided by 6. What's the opposite of dividing? Multiplying. So we're going to multiply it by 6. There's quite a few 6 because it's example 6 too, right? So we're multiplying by 6 over 1 if you want. You can do it to both sides. And the thing is when we've got, this is 6 times x in the top, 1 times 6 in the bottom, we can actually divide here 6 divided by 6, right? 1. That cancels. So we end up with x equals, as we go here, negative 5 times 6, negative 30. And again, quick mental check, if you take negative 30 divided by 6, we do get negative 5. Okay, so it works. Just think opposites. One-step problems. So far, so good. Any questions? Practice, 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 and it'll just all, because this is all it is. doing the same thing to both sides and undoing what's being done. You okay? Questions? Sure. Remember, the people that are muted out on the live stream, they're asking you, make sure you ask those questions. If you do have questions, even if you don't know what the question is. Okay, so we'll move on. But remember, we always got the, got something right behind there. Okay, so if there's one-step questions, what must else there be? Two-step. So if we can do the one-step, let's do the two-step. A couple more one-steppers, but let me do one more one-step because again, 7, we could actually think of this either as a one-step or a two-step, and I'll work it both ways, and I'll show you that it's going to be easier to think of it as a one-step problem. So 3/4 A. What are we doing with A? We're multiplying by 3/4. Okay. What's the opposite of multiplying by 3/4? Dividing by 3/4. And now I want to think is when we divide by fractions, what is the first step we always do? You flip it. You invert it. You take the reciprocal. So, and then you multiply. So that's what I want you to do in your head, is not think of 3/4 divided by 3/4, although that we could do that. When we're dealing with fractions, let's think we're going to multiply both sides by the reciprocal. Multiply both sides by the reciprocal. And what you see is you've got 4 divided by 4, and that gives us what? 1. 3 divided by 3 gives us 1. Exactly what we wanted to happen. We end up with 1A. It's not as clean on the other side, but that's okay. I can just think of this as 8/1. Can 3 go into 8? Not evenly, so we'll take 8 times 4, 32/3. Sometimes Math AS wants you to leave the answer like that, so we might be done. Sometimes they want it as a decimal. You could take 32 divided by 3, and I think you'll get 10.6666. We'll round it to 67, whatever they need to. But you could put that in your calculator if they ask for a decimal. So again, fractions are not as scary when we get to this part of algebra because we don't have to deal with them so much. I'm going to show you, there's one with like 4 different fractions. I'm going to show you how to just wipe the fractions out with one little step. And we can do this because we can do anything we want, any darn thing we want. As long as we do it. Thank you. Can I get it a little bit louder, a little bit more? So, tell I used to be a preacher, right? So get a hallelujah out of that. No, okay. So yes, an amen. Amen. We can do anything we want as long as we do it to both sides. Awesome. Good. That's our mantra. Whatever mantra is, right? Okay, so that's good. Let's take a look at a couple. These are still some one-step solutions, so actually let me take a picture of that. And then we're going to keep going. Let's clear this out. And we're going to do some two steps. A few more here, solving two-step equations. So what do you think? How is a two-step equation different than a one-step equation? It's got 2 steps. Okay. We're going to do 2 things. And so we're either going to add or subtract something, and then we're either going to multiply or divide something. So it's got both parts into it. That's really all it is. So because two things are happening to B, we have to do two things to get B taken care of by itself. I always think of this sort of, maybe because this is, whenever there was a party going on, I'd like to go to sleep early. And so if it was in like, my room and my roommate was having a party and stuff, I just kind of like, hey, everyone go to a different room, So I always think of the variable as like the grumpy old man who wants the party to end. So you kick everybody out. How do you kick everybody out? You do the opposite to them. So here's our equation, 2b minus 4 equals 12. Again, we're focusing on the grumpy old variable here, b. We want to get it, he wants to get by himself. So how does he get rid of stuff? Well, what's the first thing he's going to get rid of? The 4. How can we get rid of a negative 4? Antimatter. You do the opposite. Okay. People don't like when you do the opposite to them, so they leave. Okay. And so, but you can't just do it to one side, you got to do it to both sides. Negative 4 plus 4? 0. So then what we're left with is 2b. 12 plus 4, 16. And then now how's b going to shake the 2? Going to divide by 2. That's how you break that bond. So we divide by 2, but we do it to one side, got to do it to the other side. 2 divided by 2 is 1. B is equal to 16 divided by 2, which is 8. Okay. That's our final answer. The check is to rewrite the equation with b in there. So instead of 2b, we write 2 times 8 minus 4. I always like when I start off this, I put a little question mark. Is it equal to 12? Because that's really what we're asking. If we did everything correctly, it should be. If we made a mistake, we'll find it here. 2 times 8, 16, minus 4. And some of you, again, you could do this in your head. 16 minus 4, 12. 12 equals 12. There's our check. It worked. Okay. And you notice when you do the check, you start to see the numbers that were part of the solution as well. Here's a 16, there's a 16. We're subtracting 4. Up here we added 4. It's just, yeah. So far, so good? Okay. And again, let's just go through these, practice these two-step equations. You're doing the adding or subtracting first, and then you do either multiply or divide. Yes?
Where did B go?
Where did B go? Over here?
Oh, okay, because of the
Okay, good.
negative 4?
No. B was replaced by the 8. It's right in here.
I got
So,
you. Okay.
but that's good. Sometimes it's helpful to just actually rewrite the whole thing, and then now I can replace the B with an 8.
Okay.
Okay, that's what I did, but I skipped a step.
Well, no, I just didn't understand that that's where you put that. That's fine.
Okay, perfect. So yeah, once we find out what B is, that's all we're doing is we put it back in for it, or R, or whatever the variable is. Okay. We okay? Want to see one of these, or shall we move on to something more exciting? What's that? Number 2. Okay, because the variables changed places, but what's happening to this variable R? We're multiplying by 3 and then adding 4. So as we go backwards, what are we going to do first?
Subtract 4.
We're going to subtract 4 and then divide by 3. Okay, so the story of X is we are multiplying by 3, and then the second step is we're adding the result to 4. So when we go to solve, we're going to go backwards and opposite. So we will subtract 4 and then divide by 3. So story of X happens this way, solving happens the other way. So we subtract 4. And again, we subtract from like terms. So 4 minus 4, 0. 0 plus 3r is just 3r. 0 is a good thing, it just disappears when we're adding it. What's 5 minus 4? Just 1. And then now, what's our next step? Divide by 3. Divide this side by 3. Divide that side by 3. 3 divided by 3 is 1. That's the canceling step. So then we get r equals 1/3. Put in your calculator, it becomes 0.33, 333 forever. You get ones like this. It's actually harder to check it, but you know, we could do the check. So we do 4 plus 3r equals 5. So our step is to take 4 plus 3, and then we put the 1/3 in for r. Okay. 3 divided by 3, that's going to give us 1. So this whole answer here is just 1. 4 plus 1 is 5. 5 equals 5. Okay, so it always works out.
Those are just ways to check to see.
Yeah, so you can always, that's the nice thing with this, you can always check by plugging it in. If you make it into a decimal, sometimes you won't get an exact because in some decimals you had to round it, right? 0.333, you have to stop writing 3's at some point. So that happens. Okay. Let's go. Doing pretty good on time. You want to take a look at B? Something with a fraction?
Yeah.
Because Little Crow says the fractions aren't that scary anymore, but I don't believe him yet, right? You're not feeling it quite yet. It's still kind of scary stuff to see a fraction, right? But let's just go ahead and let's work a few with the fractions. Okay, I've got two sides to this equation, and again, we're always working with the side that has the variable, because we want that variable, that grumpy variable wants to be by itself. So it's kind of throwing everybody out. Get out of my side, let me sleep. So what's happening to the variable w? First thing, we're multiplying by 3/4, and then we're subtracting 8. Right? So that's, if we knew what w was, we'd plug it in and we would do that to it. But we don't, so we need to solve. Solving goes in the backwards order, right? So to solve, we go this way. And so instead of subtracting 8, what are we going to do? We're going to add 8. Instead of multiplying by 3/4, what are we going to do? Divide by 3/4, which is the same thing as multiplying by 4/3. The reciprocal. Multiply by the reciprocal. You'll see that this is actually the easier way to think about it when you start dealing with fractions. So if you see a fraction, we're multiplying by a fraction, just multiply by its reciprocal. That's the easiest way to get rid of it. It's what you're going to do anyway, right? If you divide by a fraction, the first step you're going to do is to flip it anyway, and then you'll multiply. So this is just going to save a step, and once you get used to just seeing that and doing it, it makes it that much cleaner. And it takes away the fear of the fraction, because you just see the fractions just, it's really, see, the fraction really has two operations going on. It's got a multiply part and it's got a divide part. And what we're doing is we're switching the multiply and divide, right? In this problem, we're multiplying by 3, dividing by 4. In the solving, we're multiplying by 4, dividing by 3. We're flipping, we're doing the inverse operations. Makes sense? Okay. So I've used up all my room, so why don't I come over here instead of the check? Well, we could go up here. So I'm just going to rewrite this out as 3/4 minus 8 equals -2. Don't have, oops, 3/4 x, sorry. Do any of you also, oh, not even x, it's w, isn't it? We could put x, couldn't we? And then change it to w later. But okay, so what's the first thing we're going to do? We're going to add 8. Whoa. Somebody touched something? Or somebody got telepathic powers? Or did we just pay our light bill? Maybe that's that was, yeah, I'd like to say I've never seen that happen, but if there's any voices with lottery ticket numbers, write them down. Maybe it's a winning ticket. Add 8 to both sides, right? So on this side, we just get used to it. That's going to become 0. We're just making zeros and ones. Those are our favorite numbers to work with. 3/4 w. We didn't do anything there because, you know, this is what we did. -2 plus 8, +6. Okay. And this is where, again, we want to just, we've already talked about what we're going to do. We're going to multiply by the reciprocal. Multiply by 4/3 on both sides. And you'll see it just takes care of the whole fraction in one fell swoop. We were dividing by 4, multiplying by 4, that cancels. We were multiplying by 3, dividing by 3, that cancels. We're left with w on this side. Now over on this side, this is where it may still be a little scary because we're working with fractions. But remember, a fraction is just one multiplication and one division. If we're not sure what to do, we could always do the multiplication first. But it's actually easier with fractions if we can see a division that we can do. Do you see a division that will give us an even number? 6 divided by 3, that's 2, right? 1 down there, 2 up there. 2 times 4, 8. 1 times 1, 1. So w is equal to 8. Okay. Does that make sense? No? Okay. Let me find you here. We'll go, and I know how to do it. We'll do it the way we were taught. We were taught to multiply straight across, right? 6 times 4. 1 times 3. 24 divided by 3 will give us 8. I'm not going to, you know, once you get used to it, to me, what I did here with the canceling is easier because I'm canceling with smaller numbers. When I multiply out, sometimes I get bigger numbers and I don't see the multiplication facts. Now, 24 and 3, okay, I could see that. But sometimes you get like 96 divided by something and you don't see that right away that it works. But when you were over here, if you can see the pieces, this is where it's actually, the multiplication facts are easier because we're dealing with smaller numbers. Once we multiply, we get bigger numbers, which in my book are harder to deal with, but it depends on how comfortable you become with fractions, okay? This did take time, many, many years. And it didn't work as a student. It wasn't until I was a teacher. Most of my best stuff I learned from teaching because students worked with me and they showed me their tricks. And so, but notice both cases we end up with 8. Now does it, that, okay. So you do it the way that works for you. And then you start seeing, see when we get it here, if you didn't see that it was going to reduce, you could look back here as well and see, oh wait, 6 and 3, those reduce, so I know the other one's going to reduce. But work through fractions the way you want. What works best for you. Okay. And again, sometimes what I would do is I would go 6 times 4 over 1 times 3. And then I can actually divide before I multiply because multiplication and division are the same. So maybe if I look at this now, 3 goes into 6, leaving us with a 2. 2 times 4 is 8. And again, thinking of it as 8 over 1, which is just 8. So, still a little bit.
Well, I don't know where you got the 1 from. I'm under the 8,
Oh.
or above, yeah. under
Here?
the 8, yeah, back, up, over, left.
This
There
one?
you go. I don't know where you got that one.
Okay. Oh, because I wrote 6 as a fraction, 6 as a fraction is going to be 6 over 1.
Yeah.
And then when I cancel out the 3, what I'm really doing is 3 divided by 3 is 1.
Oh, that's what you're doing.
Yeah, so 3 divided by 3 is 1, 6 divided by 3 is 2.
Okay, so I understand the first half.
Okay.
The 6 divided by
That's
3.
okay. Now I understand why nobody understands what I'm doing.
Is it always
Awesome.
1?
Yes.
When
Every-
you have the empty spot, you always just put a 1.
Yeah, because anything divided by 1 is itself. 6 divided by 1 is still 6. So it's another way to write 6. So that's what we do with algebra, is we find all these funky ways to write the same thing, but it's not stuff we're used to, because we don't write whole numbers as 6 over 1. We just don't. But it's helpful if we're multiplying it by a fraction. And we don't write 1x, but sometimes it's helpful to write 1x because there really is a 1 there. The 1 is like everywhere. He's like Forrest Gump. Yeah, Forrest Gump's everywhere. Yeah, he was with the president. He was with this guy. He's all the famous people. 1's always there. It's everywhere. It's just how he's in hiding too. Yeah. Forrest was like that. He wasn't, he didn't put on a big show. He just, he was just with people. I love Forrest Gump. And Bubba Gump Shrimp. I got 2 brothers named Bubba, so. Yeah. I pick them up from football practice and they look at and say, "What happened to you?" So I was the older brother, but they got the size. So okay. So far, so good. Okay. So while we're at it, there was another one I saw in here that's kind of a little bit more complicated. Let's oops, go back. Where was this? Okay, I think we were about here. There we go. Save. Okay. And we're almost done with the solving part of multi-step equations. But before let's see. While we're still on the topic of fractions, we'll come back to some of these. There was a nice one. Oh, it was in the practice problems. So I'll do that and then we'll talk about the multi-step problem ones. Here we go. Doesn't that look like a friendly problem? Four fractions, right? I guess 2 have a common denominator, but what are we going to do with this thing?
Page 92.
92, yeah, so practice problems, it's one of my students labeled this, the next step I'm going to show you. Yeah, he laughed when he said it. So very happy about this trick. When we have an equation, we got an equal sign, what can we do? What did I say we can do when we have an equal sign? Anything.
To one side that we can do the other.
Yes, and we can do anything we want. What I'm going to show you is that usually if we're adding fractions, we need to get a common denominator, right? You agree with me on that?
Yeah.
But instead of getting a common denominator, what I'm going to tell you, if you can figure out what the common denominator is and then multiply by that number, you will kill the fractions. Okay. So looking at these fractions, 3/4, 1/2, 9/8, 3/2, what would be the common denominator for all of these? The 8, because everything divides into 8. Everything 4 times 2 is 8. 2 times 4 is 8. And 8 times 1 is 8. So 8 is the common denominator. So I'm going to write this larger because it's going to give myself some room to work. So I'm just going to rewrite it as 3/4 x minus 1/2 equals 9/8 x plus 3/2. Switch pen color. So what I'm going to do is I'm going to multiply both sides by 8. And when I multiply this side by 8 and this side by 8, right, I'm multiplying the whole side, so what do I have to do with that 8? Distribute it to each of the terms. Okay, distribute it to each of the terms. Okay, now this is some advanced stuff, and it's really, if it's not singing to you or making you feel comfortable, we'll get there, and it's not that important. It won't be on the test. I'll give you that much. But sometimes if you use this technique, you can take one that looks like a very nasty problem and actually make it very calm in one fell swoop. So what do we have? It's too much red, so let's move it to green. So we're going to have 8 over 1 times 3/4 x minus 8 over 1 times 1/2 equals 8 over 1 times 9/8 x plus 8 over 1, just another way of writing 8, right, over 3/2. And this is where that technique we were using, where we divide before we multiply, really helps out. So we don't you could take 8 times 3, you get 24, and then divide by 4, you get 6. But watch, you could take 4 divides into 8 2 times. What's 2 times 3? And since all that's left in the denominator is a 1, we don't need to write it anymore. The denominators are gone. We've killed out the denominators. When you kill the denominator, you've killed the fraction. Maybe we say transform the fraction is a better way to do it, but however you want to say it, it was a student that came up with it, and they hated fractions, and this was what gave them joy, killing the fractions. 2 goes into 8 4 times. So you're left with minus 4. Isn't 6x minus 4 so much nicer to look at than 3/4? Yes. Aren't we? Isn't the stress just kind of floating away from us right now? We're going to do the same thing to the other side. And all we had to do was multiply by 8. And you see what power we have when we have an equation. Because we can do this with we can do anything we want. Okay? 8 divided by 8 is 1. 1 times 9, 9. 8 divided by 2, 2 goes into 8, that's 4. 4 times 3, plus 12. The cool part is it looks like a different equation, but both sides are still equal. And the solution we're going to end up with x that works here will also work in the same with the ones with the fractions in them. We get x is x. It will work. We followed the rules. We did the same thing to both sides, and we can do anything we want. Okay, so that's one extra step, is when you got a lot of fractions going on, or even just a few fractions, you can always get rid of them by multiplying by the largest denominator, the common denominator. And it'll get rid of all the denominators. Now, had we multiplied by 4, we would have gotten rid of a lot of the denominators. We still would have had 1, right? Because 8, but if you don't get rid of them all, you just need to multiply by a little bit bigger. Are we done yet, though? No. So now's the time I'm going to show you how to do what they call the multi-step ones. And this is basically what we do every time we've got an x on separate sides of the equal side. We got an x on both sides. How can we get x equals a number when we got x on both sides? Must be a trick. Must be some way to do it. Is there any way I could get the x's on the same side?
Can you combine the like terms?
You got it. Exactly. But, so the thing is, we've got a 6x on the left side and a 9x on the right side. How do we combine them? Because they're on opposite sides of the river.
Like terms?
Like terms, but what do? We're still a little bit rebellious. We don't add 6x. Could we subtract 6x? Can we do that?
But then you'd have to subtract 6x on the other side.
Thank you. We can't just do it to one side, but if we do it to both sides, then it's legal. Right, just to one side is not. Now, what is 6x? It's just or negative 6x, it's just a number. We don't know what it is because it's got an x there. But we know that when we take a plus 6x and a minus 6x, what are we always going to get?
0.
Exactly. And so when we got a 0, what happens? The side,
Just have x.
well, no, not even x.
Oh, no, yeah, okay, so
It's like, yeah, it's gone. 0 is 0. Not even any dust left behind. Completely vaporized. It's gone. So we just have a negative 4. I guess a little bit left, but because we didn't do anything to that. And then now we've got 9x minus 6x. Those are like terms. We can do this, right? What do we got? 3x, exactly. But now notice we only got an x on one side. 12 still comes down because we didn't do anything to get rid of the 12. This is the only extra step we have. And now we're back to a two-stepper. So we're going to subtract 12 and then divide by 3. Okay, so you see, this is what we were doing. So we start off with one step, and we kind of, as you get used to doing, we're just either adding or subtracting a number or dividing, multiplying or dividing. Then we got the two-steppers, where the x is on the other side. And then we got these where there's an x on both sides of the equation. The first step is to get the x's together, get the family together, okay, before you do anything else, And now that the family's together, we just now we got to get x by itself. And we can do it because we got one x term at least on one side. Does that make sense so far? Now again, if it's easier for you, you could flip this and work it like 3x plus 12 equals negative 4. If that's an easier way to work it, it's perfectly fine. Equal signs are commutative. We could flip it. If it's not a problem for you, you could work it over here. Either way. Any preference? This way or this way? Left or right? Left or right? Your left or my right? No, I think those are the same. We'll go with this one. We'll work them both, right? So if we're getting x by itself, you do the opposite to everything around it, dealing with the addition subtraction part first. Okay. Negative and negative, we're going to add them together, right? 16, and it's negative. And then how do we get the x by itself? Divide, exactly. Divide by 3, divide by 3. 3 divided by 3 cancels. So that's just 1x equals negative 16/3. Some people say, well, it didn't end up being an even number or integer, so it must be wrong. Not true. Fractions could be answers, decimals can be answers. And that's all there is. Again, over here, we have to, part of this thing is, see, look, we did something to the left side, but then we've got to switch back and we got to start doing things to the right side because we want to get x by itself. So sometimes by flipping it this way, again, I'll just go through, we subtract the 12, subtract the 12. And oddly enough, oops, it actually will help you and it'll work. I think you'll get better skills if you do work it both ways for a while. And again, just kind of become aware of what feels more comfortable to you. and go ahead and admit, well, one side is better than the other, and then you'll, after working on both ways for a while, you may just develop that true ambidextrous ways of thinking where you can, it's just as easy either way. But it starts with being aware that, yeah, one way is probably a little bit easier than the other. And that's it. That was a masterly big problem, wasn't it? It seemed like it. But then once we found a technique to get rid of the fractions, didn't it seem so much easier? And then we got this problem of the x's on both sides. But then we thought, yeah, we can add like terms, but when we bring it from one side to the other, we're doing it the opposite, because basically we're making one vaporize, we're turning one into a zero. And the hardest part probably of this is realizing how much power you have. Because when I work with students, they'll go, really, I can do that? I say, come on, you can do anything you want, as long as you do it to both sides. And it's okay to do something wrong, because it's not wrong if we do it to both sides. It might not make it all pretty in the first one or two steps, but there's never anything wrong as long as we do it to the same side. Some things I'll do is I'll see they'll add 8 to one side and then they'll subtract 8 from the other side. Now that's not the same thing, is it? You've actually made it more unbalanced. So that it really is, you have to do exactly the same thing to both sides. But you're going to be okay either way. This usually, we got pretty far, because usually it takes me 2 class lessons to get this far into the multi-step problems. Page 8. We got a little bit of time, so what I want to do, and then I always like to give you some time at the end for any questions and such. Oh, I already saved this, didn't I? Yeah. Hope I did. It's cleared off. Let's take a look at another one of these multi-steppers. Let's see. Of these 3 equations, G, H, and I, do you have any preference? Which would you like to see done? H. Okay. We'll do H. So, now again, we could look at the story of X and try to deal with it, but when you see parentheses, what's maybe one of the first things you want to do with that?
Get rid of those.
How? Distribute. Very good. So use all the terminology. We're going to distribute, and that will get rid of parentheses. And the parentheses are, you can look at them sort of as prisons, because they're or a house or a room, but they're locked inside that. To get at the X, we got to get those parentheses off. We got to get them out in the open, outside into the forest. And so we distribute. On this side, the -2 is going to distribute through. On this side, what distributes?
1.
A -1. Very good. So we've got this -1 that's going to distribute to each of these terms. -2 times 4. -8x. Good. -2 times -2. +4. -1 times 2. X. -2x. And a -1 times -8.
-8. +8.
Good. And now it's just a 2-step or a multi-step problem. What's the first thing we want to do here? The x's are on opposite sides of the equal sign. How are we going to bring them together?
Find a common denominator and divide. We would like terms.
Like terms. So we're going to turn one of them into 0, and then the other will be what it be. So which one do you want to turn to 0?
Doesn't matter which one?
It doesn't. Whichever's more comfortable. So we've got 2 things we could do. Which one would you like?
-8.
Take the negative, so get rid of the more negative one, because I like to deal with positives. If you're like me, negatives cause me problems more ways than one. Yeah, negative things in life, we want positive things in life. So we can get rid of the -8 simply by adding an 8x, right? Like terms. If we add it to one side, we do exactly the same thing to the other side. And if you focus on making your x's positive, that makes lesson 4 even that much easier. Because negatives, when inequalities, the negatives actually cause an additional problem. So making your variable positive, it isn't required, but it's helpful. Notice we could have added 2x to both sides. It would have got rid of it here, but then we'd be left with a -6x, right? So a -8 and a +8, that's 0. So we're left with a +4 on the left side. The right side, -2x and +8x, gives us a +6x. We just write it as 6x plus 8. Bring that down. And now it's just a two-step problem. And again, you'll need to practice and get used to it, but you'll be doing these in your sleep too. So, oh, great. I thought that was my dreams were at least free from math, but now you'll actually see once you start dreaming in math, it's like, have you learned a second language or foreign language? And then when you first start to dream in that language, actually I can dream in Thai. My wife speaks Thai. I can't actually speak Thai in the living, a few sentences maybe at best. But I've had dreams where I'm fluent in Thai. Yeah, and it's just kind of cool. It's just because you're around it so much, you just go, it's like in the real world, I don't know, something's holding me back, so I just keep wanting to be, my dream world open up, I can fluently speak in Thai. And sometimes that happens with math. You'll get into your dreams and you'll be actually doing some math and it's just all naturally happening and you're going, why can't I do that when I'm awake, right? Okay. You'll get there. You'll get there. That's what we're working towards. So we want to get the x by itself. What's the next step? Opposite of 8, so we're going to minus the 8. And again, whatever we do to one side, we do to the other. So this is going to give us 0. Plus 8 minus 8 is 0. We end up with 6x. Nicely so far. A 4 and a -8, opposite sign, so we subtract. That's going to give us 4, but it will be a -4 because 8 is larger in magnitude. -8 is not larger, but. And then what's our last step? Divide by 6, because we're multiplying by 6, so we divide by 6. Do it to both sides. On the right side, it cancels. 6 divided by 6 is 1. So we're left with x equals -4 over 6. This can reduce to 2 over 3, 2/3. So -2/3 is our answer. And again, sometimes that looks weird or feels weird, so we could just rewrite it as x equals -2/3. Both are correct. Both are fine, whichever way. And again, as you work with algebra, you should hopefully become comfortable with both.
Is -6?
-6 where?
It is
This one? This is negative because... This one? Yeah, this is a +6 because we're dividing, because we had a +6x on the right side, so we divide by +6. Yeah, that's another thing that kind of I see a lot of students in the beginning, they want to, because if it was a +6, we would subtract 6. If it was a -6, we would add 6. And so when you're dividing, sometimes you want to divide by the opposite sign as well. But when we divide, we want to divide by exactly the same thing, because what we want left behind is a +1. Okay, does that make sense? Yeah. So, yeah, if we have 6x, if we divide that by a -6, when these cancel, we're left with a -x, and that's not what we're looking for. This really still has a -1 here. So if we've got a +6, we want to divide by a +6, so we get a +1. Good call. And again, we could put it back in and check it, but I don't know. I like to just check my work because that's easier than plugging a fraction back in, because I'll probably make some mistakes if I plug a fraction back in with all that other stuff that's going on. So I just carefully make sure that my steps were correct. I distributed correctly. Yeah, that looks good. Yeah, that looks good. I added, okay, that looks good. But again, we could plug in negative 2/3 up here and do the math on it. It's just, it's more work than I think is necessary. Sometimes you say, well, it matched the answer on the test, so I'll just stick with it. Okay, especially with these. Okay, how about I? Again, nothing to distribute here. This one we would have to distribute the negative. This one we distribute the 4, combine like terms, get the x's on the same side, and then we're just adding, subtracting, dividing. Okay, so while these look like yes, there's several steps in there that we have to do. Each of these are really good practice. You'll get to the place where they help you with order of operations of things, and that's one thing with math is, with math we're just doing 2 things. We're combining 2 things at a time. The problem is if we do it in 5 or 6 steps, and if it's easy, it is just as easy to mess up a step or to do it in the wrong order or something. But once you get down how it all works, it really, step by step, you get your way of thinking through each problem. It's a piece of cake. And then you're like those 7th graders in Kazakhstan who are just, winning every time you play chess. They're winning every time you do math because you've got it down. And you've got your way of thinking logically through 5 or 6 steps of problems. You just look at it and you see, oh, I do this, then I do that, then I do this. And then you'll find yourself doing it. You really will. But I think part of it is, an educational system, we focus, especially at high school level, so much on showing your work the way the teacher wants you to see the work. And we don't always think the way the teacher wants us to have our work down. We sometimes skip a step. The teacher skips a step, right? We skip steps, but it's not that we skip them, it's just we do multiple steps in our head. And then you're asking me to write down things that I just did so quickly, I forgot what I did, but I did it correctly, so why should I have to go back and recreate it? So I think that's part of the problem. And if we get, again, I highly subscribe to the way they did math in India, which was all mental. They didn't like writing things down. I need to write some things down, but I like the mix. Writing some things down that I need, but also feeling confident that I don't have to show all my work if I can get the correct answer, if I can consistently get it right. But it's helpful if I can show enough steps so that I know what I did 2 days from now, because I've done some things. I've got a right answer and I look at, how did I get that? You got to have a few notes of how you got to what you got so that you know what you're doing. And then that's going to give you the flexibility to solve problems, to calculate in a way that works naturally for the way you see the world. And each of us has it a little different. Each of us would do it a little different. But as you see, it's not wrong. We have a lot more flexibility when we get to algebra and solving problems. As far as order of operations, we can violate rules as long as we do it to the same, keep things balanced. Let's see, what else do we need to do? I think this is it. Let's take a look. Did I take a picture of this one? This is 9. Nope. Okay, so that one's there. I think we're just about through. Oops. Yeah, we're into the applications. We rock. We got all the way through 3. So what we can do is on Wednesday, we'll take a look at a few of these applications and I'll show you how I think my way through some of these word problems. And you're going to see I don't read them. I find numbers, I find equations, we work it out that way, and then we read it to figure out what it is, but we don't read it at first. But it's just going to be an application of everything we've done so far. And then we'll start a little bit into 4, which is just the same thing we did, except in starting with equal sides. One side's a little bit, it's off balance, but what we're going to do is we're going to keep the same amount of off balance, and that's how we're going to solve it. Using the same techniques we use today. Okay, it's really nothing different than what we have today, just that we don't have a balance at the beginning, we're off balance, but we keep the same amount of off balanceness and we're able to solve, just like we did today. So, not bad, huh? Okay, awesome. So I'm going to shut down the live stream. Thank you folks for attended by live stream. We'll be back on Wednesday, working more on lesson 3 a little bit, applications, and then jumping into 4 and in good shape. Awesome.